manufacturing, like all sectors of the economy, is changing over time. You know, if you go back a couple of 100 years, agriculture was somebody with a piece of wood dragging a line in the soil and then trying to sow something that would grow, and they were hand captured when it was finished. Today it's a highly sophisticated, mechanized, robotized, biotechnology based activity. So there's nothing strange. The same happens with all sectors, including manufacturing. So what used to be, if you go back to the beginning of the Industrial Revolution, quite a nasty place, you know, dirty, noisy, dangerous, children working in order to make a living and not necessarily living that long. All of that has changed, but it has changed in phases. So of course we went through the area of standardized manufacturing, bending steel and so on, and then we had robotization period, so productivity dramatically increased using automation and digitalization. And what we now have is 4 different domains that are evolving and hence enabling us to dramatically change manufacturing in exactly the way we want it to you know, nicer, cleaner, more exciting and more productive. Those 4 areas are continued digitalization through ICT, so information communication technologies. And that, to take examples, this is where you're having virtual reality. So in other words, you can see on your phone things that don't exist out there because the computer overlays it on the reality, and that can help you. Sometimes it's called augmented reality. Then you have issues around the ability to do digital printing, so we can manipulate atoms, so we can print 3-dimensional objects. Already in plastics we can do that very, very profitable, and sometimes even more profitable than traditional manufacturing, up to unit sizes of 1,000. And this is very similar to what happened to the printing industry in the early 1990s, where digital technology entered the printing industry. And like in the manufacturing industry, you will end up with 3 groups. You will end up with the people who said, this has no implication for us, the old technology is better. Most of them have died and are no longer around. The second groups are those who says, we will embrace this technology, and they ended up actually changing their business through new technology, are doing absolutely fine. And the final groups are a lot of companies that emerged that did not exist before. They were enabled by this technology. So the same will happen in manufacturing. The second technology domain is nanotechnology. So that means actually just manipulating things on a very small scale. So we are able to change the characteristics of materials. We're able to decide how a material should behave and then make it behave that way. So this nanotechnology enabled engineering will dramatically change what we're able to do with material and the type of materials we're able to create. And of course that will have dramatic implications for our day-to-day lives, not having to deal with things that rust or corrodes, or not having to deal with things that are not really the way we want them to be. So you know, we can have materials that are like memory metals that are much faster returning to the original shape when you had a little bang with your car. The third one is, of course, biotechnology. Biotechnology is the last of the big sciences, you know, in other words, physics and chemistry, that has become an engineering science. And the difference between a scientist and an engineer is that a scientist discovers those things that already exist. We just didn't know they were there. Whereas an engineer creates the things that do not exist. So an engineer builds a bridge, and before that there was no bridge. So biotechnology has now become an engineering science, and that means, of course, we can create organisms that did not exist before, and we can make those organisms do things that we want them to do. And this is classically called synthetic biology. But let me give you an example of what this will mean. 2 ways. Firstly, our ability to understand how to put existing organisms to use, and chemistry and so on around that. And the second side is the ability and the opportunities created by creation of organisms that wasn't there before. So let's talk about something which is a biorefinery. What does that mean? It means that we put biomass in one end. The biomass is anything from straw left over by the farm to pieces of branches of wood that are left over when we chop down the trees. So we put some form of biological organic material into one end. And we can then use chemical structures, yeast type activities and chemistry to break those things down, convert them into sugars, and then use those sugars with bacteria as another type of system to create chemicals for us in a way which has very low impact. Or, instead of doing all that, we could create a nice little bacteria that sits there in the sun, operating like a normal green thing. So it uses chlorophyll, extracting energy from the sun, extracting carbon dioxide from the atmosphere, and a few other things. We feed them a few bit of nutrients of other type of materials that they need, and then they use all those things to produce exactly the chemicals we want by drawing on things that sits around it. So we have two types of technologies. One is, in a sense, an engineering extension of what we are already able to do, primarily taking technology from the food industry, where yeasts and so have been used for a very long time, and putting engineering systems around that. So that's a phase one, and that we will see quite a lot coming up around the coming 5 to 10 years. And then synthetic biology is the next wave that maybe 10 years from now will start to take over from the classical technology, and we will just draw on the things around that. And of course, one of the key advantages is that we are reducing the CO2, the carbon dioxide in the air in this way, but that's a small side issue. So biotechnology will of course dramatically change some industries. We see it already now. Pharmaceutical industry has already started to change. Most long molecules are now produced by biotechnology means rather than by chemical synthesis. The next step, of course, is food industry, where we've used it a long time. But most manufacturing firms, in a more classical sense, will also be dramatically impacted by this, because it's about how you treat your effluents, the leftovers, how you extract minerals from these things. Mining companies will be dramatically impacted by this, because we are able to dramatically enhance the performance of things like biomining. In other words, you pour a sludge of some bacteria across very low-grade ore, and it seeps through and comes out at the end, and then you kind of boil away all the bacteria, and you're left with all the metal you wanted. So these are critical things that will impact. The final technology is what's known cognitive science, and that's where we operate with neurons, whereas the biotechnology side operates with genomes. We operate with neurons and the cognitive sciences. And that means an understanding of how the brain works and how people behave when they are exposed to information and how to store information. This has dramatic implications for two areas. One, for the way we as human beings are able to learn and interact with machines. And the second one, of course, is for the emulation, in other words, the copying of the way we behave into computers. So we'll have much better artificial intelligence, and that means that machines will be able to do things that they couldn't do before. So if you combine that also with the development of ICT around processing speeds, we will, we are moving into a scenario where we will be able to have intelligent computers coming around. Now, a number of years ago, a computer was on the level of a cockroach. It is now migrating around nowish into like a small mammal or a large reptile, and then it will migrate from there. And around 2030, the progression is we will have computers which are approximately as smart as we are. And I'm not going to speculate on what they will decide to do about us, or as one famous science fiction author wrote on as an epitaph of the human race: the artificial intelligence did not hate mankind. The artificial intelligence did not love mankind, but the artificial intelligence needed the atoms that human was made up for better things.